ได้รับเกียรติให้มาเป็นผู้ดำเนินรายการสำหรับการประชุมวิชาการครั้งนี้ในตอนเช้านะครับก็เป็นสิ่งที่น่ายินดีมากนะครับที่เราได้มาพบเจอกันและก็ชุมนุมกันในวันนี้เป็นงานแสดงเทคโนโลยีทางวิศวกรรมปฐพีครั้งแรกของประเทศไทยและหวังว่าจะมีครั้งต่อๆไปในปีถัดไปนะครับผมเห็นว่าหวังว่าโอกาสลักษณะนี้จะเป็นโอกาสดีที่เราได้มาพบเจอกันเพื่อที่จะนำพาให้วิศวกรรมปฐพีของไทยเนี่ยเจริญรุ่งเรืองยิ่งขึ้นทัดเทียมอารยประเทศนะครับก็หวังว่าจะเป็นอย่างนั้นนะครับสำหรับกำหนดการในตอนเช้าเนี่ยเราจะเริ่มด้วยKeynote Speaker นะครับซึ่งวันนี้เราได้รับเกียรติจากมิสเตอร์เจมส์ซีจากบริษัท OV อาหรับฮ่องกงนะครับท่านจะมาพูดเกี่ยวกับเรื่องการออกแบบแล้วก็การก่อสร้างการขุดดินลึกในเกาะฮ่องกงนะครับ ประวัติย่อๆของ Keynote Speaker ของเราเนี่ยจบการศึกษาทั้งระดับปริญญาตรีและก็ปริญญาโทจากมหาวิทยาลัยฮ่องกงจากนั้นก็เริ่มทำงานที่บริษัทอารุปตั้งแต่ปี 1995 นะครับแล้วก็ทำเรื่อยมาจนกระทั่งปัจจุบันเนี่ยเป็นไดเรคเตอร์ของอารุปที่ฮ่องกงซึ่งมีสตาฟมากกว่า 2,300 คนนะครับเป็นบริษัทใหญ่มากนะแล้วก็ Keynote Speaker ของเราเนี่ยก็ยังเป็น Fellow ของฮ่องกง Institute of Engineer นะครับคุณเจมส์ซีเนี่ยมีประสบการณ์อย่างมากมายจริงๆในงานเกี่ยวกับ การขุดดินลึกในหลายๆที่ไม่ว่าจะเป็นฮ่องกงแล้วก็ในเอเชียตะวันออกเฉียงใต้นะครับ เดี๋ยวผมจะขอบรรยายอีกสักนิดหนึ่งเป็นภาษาอังกฤษก็แล้วกันนะครับเป็นการแนะนำKeynote Speaker ของเรา Ladies and gentlemen, it is my great pleasure to welcome our guest speaker for this morning, Mr. James C. from OV Arup, Hong Kong. James got his bachelor and master from the University of Hong Kong, and then after that, start working with Arup. Okay. And then from now on, from that point on, he has been with Arup, and then he is now the director of Arup Hong Kong, which has more than 2,300 staff members. Okay. James is also a fellow of Hong Kong Institute of Engineers. He also practices in several countries around the world, including Hong Kong, Thailand, South Korea, and Vietnam. With that brief introduction, ladies and gentlemen, please join me in welcoming our keynote speaker for this morning, Mr. James C.
Thank you. Apologize for keeping you waiting because the safe in my room cannot be opened. So I keep my computer inside the safe. It's too safe anyway. So it's glad to be here, and I worked in Bangkok around 20 years ago actually. I worked several months in Bangkok for a project that they never complete. That was the Hopewell project. All right, so it's my pleasure here to share with you some design and construction aspects of the deep excavation works in Hong Kong. And that might be slightly different from what you are doing every day in here. So I hope you enjoy. So I divide the presentation in several parts, and it's quite long, I mean, in terms of the number of slides, but I will try to show more photos rather than many works, okay? And so first of all, I would like to introduce a bit of the Hong Kong Institution of Engineers. Hong Kong is very small, right? But we do have a lot of engineers because of special kind of nature of the ground, nature of the constraint, etc. So the Engineering Society was established in 1947, and then the Hong Kong IE in law was established in 1975. And currently we have over 22,000 members, okay? And we have 19 divisions, so including structural, civil, geotechnical, etc., etc. And in terms of the geotechnical group, so the group was formed in 1980, actually quite early. It's related to the first railway development in Hong Kong. And thereafter, the geotechnical division was formed in 1987. So far, we have more than 4,000 members in geotechnical division, including around 200 fellows and then 3,000 corporate members. The remaining are mainly graduate members and a few student members. All right, so I've mentioned about Hong Kong, very small. I mean, Hong Kong currently is only around 1,100 kilometer kind of like square. And compared to Bangkok City, it's only 70% of the Bangkok City. And then only 14% in terms of area of the metropolitan of Bangkok. So it's tiny dot in the world. And the most kind of like problematic in Hong Kong is kind of like hilly terrain. So a lot of hills, mountains. So in terms of the country part, okay, in the hillside, we don't usually develop. They still remain green, okay, over the territory. A lot of green places. So we don't have development over those areas. They are protected, actually. In law, we cannot develop, okay? So the developable area is less than 50%. You can imagine, in Hong Kong, we have more than 7 million people, okay? Compared to the Bangkok City itself, relatively similar, actually. Bangkok City, I looked through, is around 8 million people in the central Bangkok. So similar, but we have only less than half of the space, so very tight, okay? And every year we receive more than 50 million visitors, okay? They travel in, travel out, so a lot of people we need to accommodate. So given all this kind of like factual data, so many developments need to go underground, right? So at the moment we have kind of like railway systems in the gray line, you see this gray line, and then currently we are building the new kind of like lines, like the red lines, green lines, okay? They have different names, but these are the new kind of like railway development, and they are all underground, all right? So major infrastructures, we push it underground, road tunnels push underground, and also some storm drain tunnels, like the Malaysian one, we also go underground. And in terms of the building projects, and every year, because Hong Kong is very small, right? So the government release the land bit by bit every year. So only, not very big, only 33 hectares per year. Small place, but they are kind of like divided into different sites around the territory. So many sites actually from this 33 hectares. And then government also promote public housing. So that's around another 40 hectares. And they're also regenerating the new developments from the old districts, like the low-rise house, they knock it down and then build the high-rise ones. So altogether, perhaps roughly is about 80 hectares per year. And for these new developments, most of them will contain underground space. For example, like for the car park, for the palm rooms, and some in the busy districts, they are for commercial usage, okay, for retails, for example. So all these require underground constructions. So in my paper, I showed you some common type of excavation works in Hong Kong. So I think the most common one may be also here for the shallow excavation, maybe ship power wall, steel ship power. Hong Kong, we use a lot of steel. I mean, for temporary works, they all go with steel. So ship power wall have a beauty of the strength compared to the steel ratio, the weight ratio is very high. So you get very high strength with very little material. So, and also it has kind of like function of reasonable seepage cutoff. So for example, this development, it is nearby the seafront, okay? Nearby the seafront, and use the ship power and even with sandy material, it provides reasonable seepage cutoff. So you don't need other measures to stop the water flowing in. The water table in the waterfront is very high, you know that. And so they normally drive in by hammer, okay, pitch by small hammer or by the vibrator. And in more recent years, this kind of like silent pillar, as invented by Japanese, is more popular, in particular for infrastructure in urban areas. So they cause little vibration, okay? And what it uses, it utilizes the reaction from the early installed ship power. So they have clamps. There's several legs, okay? Several pair of legs that can clamp against the installed ship power, like this one, and then to provide the reaction to press the upcoming ship power into the ground. So it has beauty of, it can be installed in narrow kind of like sites. Also, it's very static, okay? It's just press in, okay? It doesn't require any vibration or hammering action. So this becomes more popular now in Hong Kong for major infrastructures in urban area. For example, this kind of like site is next to the old buildings in busy districts, okay? And because of the ground condition, I think the steel pipe wall perhaps is another very popular kind of like system in Hong Kong. What is it? It's actually a circular hollow section of steel, okay? It kind of like bring down by drill bit, kind of like eccentric drilling, okay? So the hole actually forms slightly bigger than the casing, and then the drill bit will bring the casing down. So this has a beauty of overcoming the obstructions, like the core stones, like the boulders in the field and in the in situ material. So this is particularly useful in the kind of like hilly terrain area. And in the kind of like siphon area, they do need to have some grout curtains behind the wall in order to stop water coming in, right? So sometimes it causes some problem because they actually form a hole bigger than the casing, and they use the high pressure air to flush the material. So sometimes it causes kind of like subsidence, okay, with the old techniques in terms of the drilling process. So nowadays we use more advanced technique like the ring bit. So you have, apart from the drill bit itself, the ring also help to drill, okay? So the ring is attached to the casing, okay? So it has the ability to drill down as well. So this kind of ring bit system, okay? So it's more popular now. So it causes less disturbance to the ground. And soldier power is a variation of the former wall actually. We install, the typical technique actually, we install the steel casing, and then after that we insert the X section, and then we withdraw the kind of like the temporary casing. So the construction technique in fact is very similar for soldier power wall and the kind of like pipe power wall. And you may be more familiar with ball power wall actually, ball power wall and also diaphragm wall. So in Hong Kong, we don't kind of like, it's not very common to use ball power walls nowadays because of the construction technique I'm going to tell you slightly later. So in some cases, we may use second power wall, so overlapped basically, overlap the primary piles together with the secondary pile, and it has the ability to form an arching effect, okay? So this kind of wall, for example, like the left-hand side, this actually is a circular shaft. A shaft go to very deep, around 60 meters, in order to go down to the cavern, in order to build the railway. So roughly it's about 25 meters in diameter. So it's formed by bigger kind of like primary pile, and then smaller kind of like secondary pile, and then form a circular cover dam. So you don't actually need any lateral support in this kind of cover dam. So occasionally we may use this, or we may have some contiguous ball power wall, so isolated, and then you may have ties or struts to support the wall. But of course, if the groundwater table is high, then we do need to have some other means to stop the water coming in. For example, like in this photo, you may see it's very, very red, right, down there. Actually, the water is leaking. So this wall is not the ideal one, actually. And construction of the ball piles, I mean, in Thailand or in other coastal areas, it's more common to use this caliber technique, right? And because of the soft material. So use the caliber mounted buckets, you can kind of like excavate the material, and then use the bentonite to support the kind of like the power ball, or polymer to support the power ball. But this kind of technique is seldomly used in Hong Kong, unless this particular site that with good ground condition. In many cases in Hong Kong, we have kind of like non-uniform field. So you have boulders, you have different material in the field. You then come into alluvium or marine deposit, and then they decompose granite or tuff. And there are lots of core stones down there, okay? So in the more common technique, actually, so the technique, actually, we use the full length casing. So all along the ball pile, we use the casing. And then we use the water as the kind of refreshing medium, and then grab through the soil. And when it comes to the obstruction, we use the reverse circulation drill, okay? Drill through the obstruction, and then sink the casing again, all the way to the formation level, the founding level. So this kind of technique actually is very safe because you use the full-length casing to support the pile. Because of the ground is not homogeneous, so actually if it falls, the boulders would drop into the power ball, and the power becomes bigger and bigger, right? So to prevent the collapse, we use full-length casing, and then after using the reinforcement concreting, and then we extract the temporary casing. So this kind of like construction technique is very safe, but it's time consuming. For example, in here, if you build a 60-meter bore pile, you may take only one shift, maybe 12 hours, at most maybe 18 hours in here. But in Hong Kong, if you build this same dimension of pile, it may take roughly about 5 days. So it's very time consuming. So that's why the bore pile wall is not very common used as the retaining wall, because you have very large number of quantity, right? For the diaphragm wall, and also you are familiar with diaphragm wall as well, because you have lots of MLTA development nowadays. And it's a linear kind of like feature, linear aligned kind of like panels. So typical thickness in Hong Kong similar is 800 mm to 1.5 meter, okay? So the panel length on plan is 2.8, minimum is 2.8, up to around 7 meters, okay? And so the construction technique, I think, is similar, both in here, in Hong Kong. We use scrap to start with, but because of the material, in some occasion, it's very hard. So we may use the trench cutter in that case, so that has better ability to overcome harder material than the rich soil, okay? So now comes to the support. So we talk about the wall. How about the lateral support? So for infrastructures, it's very common to use this type of, we call braced support. So from this wall support to that wall, okay, self-support within the site. And for example, this is a railway station, roughly about 300 meters, and by kind of like 25 meter wide. So that gives you very kind of like regular pattern of the structures, right? And then you don't really affect the land outside. So this is very common in Hong Kong, and also in the urban area, we cannot have any support outside the sites because next door is already the building nearby, right? So this is almost like the default, you can say default supporting system in Hong Kong. And in some occasions, we may be able to use anchors, okay? But only few sites, for example, like if we can get the land, okay, for temporary use or permanent use. So some anchors are actually retrievable. You install the anchor, and then you can retrieve the strands afterwards, okay? So they only leave the anchor body in that kind of like segment in the ground left in there. But after all, the cable strands can be pulled out after. So we have few kind of like sites use this kind of like technique, but not common actually. And top-down construction in Bangkok also for some railway stations, they also go for top-down. So you use the slab because they need to be built anyway in the long term. So you use the slab as the lateral support, okay, with some steel stanchions to support vertical kind of like the load from the slabs or from the superstructure, and then you excavate downwards, okay? So this has kind of like beauty of minimizing the use of temporary struts, all right? And one variation, in previous slide I've demonstrated about the circular cofferdam using bore pile wall. Actually, more common is to use diaphragm wall. So for example, like this cofferdam is for the ICC, the highest, tallest tower in Hong Kong. It's 76 diameter, 76. And we use the diaphragm wall in segment such that they can form a circle. So it utilizes the kind of like the hook action to support the wall itself, like a drum, okay? And so actually you don't need any kind of like structures internally, okay? These ring beams, actually, they are more to comfort the government official, okay? I can say that. In reality, if you do an analysis, these ring beams has no real function, actually. They are too weak compared to the wall itself, okay? But to make them more comfort, usually we maybe have 1 or 2 ring beams inside. So also you can see from this photo, these are the barracks, actually, barracks foundation for this highest tower in Hong Kong. And now comes to the design aspect. Okay, so the design practice in Hong Kong for structural works, we all go into limit state design. Okay, so we check for the serviceability limit state. We also check for the ultimate limit state. But for the geotechnical design in Hong Kong, still we are following the working stress approach. So we do analysis for the working stress condition, and then we use a load factor to factor up the results in order to get the force for the design, okay? So these are very old publications, but still we are following these codes, like the GeoGuide 1, GeoGuide 1 is Guide to the Retaining Wall Design, and we get some parameters from this publication. And then this publication is only guideline in Hong Kong that actually provide some design requirement and code requirement, something like that. And it's very old. It was published in 1990, so 24 years ago already. So I assume they will update soon. And more recently, not recent actually, this was published in early 2000, right? But in Hong Kong, we only adopt this kind of like code in recent years. So this has entered into limit state design age, okay? So the serial report was published in the UK, okay? So it used the concept of limit state design. And now it kind of like in conjunction with the Eurocode. So all Eurocode are limit state, okay? So this is a change of the design practice from the working stress approach to limit state approach. Unlike Bangkok, you have substantial water drawdown, right? Because of the historical use of water. So the pore water pressure actually drops at lower upper sand or lower sand area. But in Hong Kong, we are under hydrostatic condition. So in that case, you can imagine in the seafront, the water table is just about 2 meters below the ground level. So in typical ground condition, the groundwater, okay, in Hong Kong actually dictate the design of the excavation works. So because it kind of like contribute more than 70% of the force. So the soil kind of like load only small portion of the load, but water is dominating. And there are few kind of like stabilities we normally check. One is the toe stability, of course, toe kick, okay, because there are two issues. One is about the ultimate limit state, whether it fails, okay, whether it will fail. Second is whether it will move a lot, okay, so such that it may affect the adjacent roads and the adjacent buildings. So the factor safety apply actually is quite high. We are talking about on passive, we are applying factor safety of 2, okay. Compared to other cities, this is a big kind of like value actually. In particular, in clay, you can never achieve this factor safety. And also, I talk about water. So hydraulic failure is another critical factor because no matter it's alluvium, CDG, okay, the decomposed granite, they are all relatively permeable. They are not clay. So the hydraulic failure is another critical case that we need to check. And in this case, we check for 1.5. So in terms of the software, so I think nowadays, no people will do hand calculation, right? So they all go with computer. And this is a kind of like boundary element method. It's not finite element. It's kind of like pseudo finite element method, you can say. And Flu actually is quite popular in Hong Kong and elsewhere. It was developed by Oasis. That's part of the Arab actually. And it's very quick to run. Actually, you can simulate different stages of excavation. So compared to structural design, staged kind of like simulation is very important because the lock-in force under every stage, okay, that will accumulate to a big force compared to the structural design. So total different concept. And nowadays, I think many people, go for finite element, okay? So this actually has a beauty of very quick to run. So the initial design check, we may use this software. And then after that, if we need to go into more kind of like accurate, you can say accurate kind of like estimation of the ground movement outside, and then what's the effect to surrounding, then we may go into finite element. Like I think some of you may be aware of Plexus, for example. And then we have other software like Safe or kind of like Flat, for example. So this kind of like software, the beauty is able to give you the deformation outside the retaining wall, such that you can estimate the effect to the surrounding ground, to the surrounding structures, etc. And in some occasions, we do need to have some three-dimensional analysis, okay? In kind of like some PhD kind of like students, they may be very keen in developing kind of like 3D techniques, like the Midas or Plexus or whatsoever kind of like Abacus kind of like software. And I think in Hong Kong, for commercial use, we don't usually go into 3D analysis. First of all, programs in Hong Kong, they do need to pre-approved by the government. So such system is very complicated because you need to validate your software before you can use it. So imagine, how can you verify a 3D analysis? you need to use another software to verify it, right? So it's kind of like enter into a very complicated kind of like situation. And so in most kind of like cases, we use 2D analysis, and in some occasions, we may forced to use 3D analysis. So I briefly talk about the limit state design approach in this C580 approach, so published by Serial Report in the UK. So we have our own partial factors, okay? In Hong Kong, we adopt our own partial factors to replace the partial factors stated in the code, okay? And these factors basically follow the red book I showed earlier, that's the GeoGuide one. So we factor down the strength, and then we factor up the loads, for example, like surcharge next to your excavation, okay? So that gives you the ultimate limit state. So this enter into this part. So we carry out the ultimate limit state with the partial factors parameters, and then some construction considerations in the excavation as recommended by Serial Report. And then we got the ultimate limit state forces in the props, in the walls, etc. And also we study the toe-in requirement. So now we are not checking against a factor of safety too. We run the ultimate limit state analysis, and then to test where the wall should stop before it fails in the finite element analysis or in fluid analysis, okay? In any kind of computer analysis, we test out where should the wall stop, and that is the requirement that we require, okay? And this is the ultimate limit state, and then we also check the SLS, the subjective limit state, to estimate the ground movement, actually, the ground movement or the movement next to your building. And then the kind of like the SLS forces. And how to decide the members then is to compare this force, okay, from the ultimate limit state with this works would not go wrong, okay, in terms of the structural member design, etc. And of course, compared to the conventional methods, conventional method will only check this, okay? We check the SLS, and then use the load factor to calculate the member. And then we omit the ultimate limit state, okay? So this one becomes more kind of like robust in terms of the design. And it's increasing trend to be used in the major excavation, okay? So for example, like this one, the beauty is, for example, if we have a toe-in, for example, like this sheet pile wall, we have excavation of -6, that is 11 meters below ground. And then the toe actually go to another 10 meters below the final formation level in kind of like sandy material here. So we test, okay, in the ultimate limit state, we test the toe-in from 10 meters to 9 to 6 to 5. Actually, it's still stable until it raise around 4 meters, okay? If you raise going up, then the wall will fail, okay? So we test for the toe, and then we also study the kind of like the bending moment forces, okay? It doesn't change much, okay? So this will give you the where the wall should stop, okay, as the bare minimum, okay? That's the first requirement. Of course, the second requirement is the groundwater cutoff, because when you raise the toe, the kind of like the path of seepage getting shorter, it may enter into seepage problem, okay? But in the former slide, you can see that in this project, because of the requirement, they have grout curtain anyway at this portion. So if you raise the toe, the grout curtain actually go higher up, okay? So it compensates the overcome the seepage problem, okay? So if in this kind of like project, actually we can save on the toe requirement. And remember, this is not just the material, because in Hong Kong, as I mentioned, there are lots of obstructions in the ground. So if you can drive the pile, the wall shorter, it has a big advantage of you not try to overcome the obstruction in greater depth, okay? So it's program issue and the risk issue actually, yeah, not just the saving the material. So now I briefly describe one project which is undergoing at the moment. We have adopted 3D analysis. This is very complicated. If you go to Hong Kong and then if you need to go to Ocean Park or other places, you may change from the subway to bus, okay? So this is the station, underground station actually, 5 level basement. And then there's kind of like interchange station for 2 lines. One, we call it the Chin Wan line. The other one is the Island line. So interchange of 2 lines. and then with a commercial basement already in blue, all in blue color here, okay? So these are the kind of like the old tunnels formed by compressed air, okay? Compressed air method excavated. So within this area, we need to build another station, okay, new station. Actually, it's deeper, okay, occupying the entire space, and then we go underneath the existing station by another 2 stories, okay? So the kind of like brown color, and then like this is 5 level to provide an interchange for another 2 lines. So totally there will be 4 lines interchange at this station. It's the most busiest station in the future. So this station the line will go into the right line and then allow for another line to go out in the future, okay? So the cross section is like this, okay? It's very deep. So current station or platform is at roughly about -18, that is about 22 meters already. And then we need to go for all the way from the ground to 40 meters, okay? From 4 to -36. So the kind of like the geometry is very tricky, right? You have existing structure like this, you have another car park there, you have some areas we need to stop, and then to minimize the on-grade. This car park actually is on-grade, okay? They are not supported by piles, okay? So we need to carry out some complicated kind of like 3D analysis to look at the corner effect, okay? Actually, we try to estimate the movement and the forces in more accurate manner. So this kind of like analysis. So this is the bedrock, and then we need to actually cut into the rock. So this is the deformation shape, like the deformation of the ground, and on the car part, behind circular thing is the existing tunnels, and then the existing platform for that line, okay? So deformation shapes, the movement extends, for example, deformation extend, and then the stresses, okay? This stresses is related to the stability of the existing platform, actually. Is in use, okay? During the time of the construction, is in use. So this photo, this is the existing platform, the bottom of the platform, actually. So we need to excavate all the way down to somewhere here, okay? This photo is taken in the last month, actually. So also we need to mine underneath the platform, okay? So we need to support it, underpinning the bridge, okay? But this is all underground, 20 meters below ground. So we need to underpin the platform and then to excavate underneath it. So we form some pillars. We left the pillars and then mine through this area in orthotic manner, mine through it first, and then build a structure, and then come back and then break down these pillars and build the remaining section. So the entire station is a very complicated kind of like construction, actually. All right, so one distinct requirement actually in Hong Kong compared to other cities may be the site supervision requirement, okay? In some countries like in China, so the designer produces the design, and then so-called an independent concerned supervisor will supervise the work. But the supervisor may not even know what the design is. See what I mean? It's so-called independent because contractually or the kind of like taking the responsibility is independent company. However, that company may not have the knowledge on this kind of like design. So Hong Kong, we go into very different kind of like approach, okay? The designer himself need to take care of the supervision role, all right? He look through the construction process. Even though the contractor may have their own alternative, sometimes they may produce alternative, but the designer know the site constraint, know the kind of the entire project. So the designer still look through the entire process. And in mid-90s, Arab and the government looked through all the case histories because by that time there are lots of kind of like incidents incurred by excavation works. So a lot of failures, okay? So we look at a lot of case histories like in the old days we still have caisson wall, okay? But nowadays we don't have caisson walls. Sheet power wall, diaphragm wall, pipe power wall, etc. So in total, every year in Hong Kong in early 90s, roughly it's about 100 to 200 cases of excavation works. Some are minor, some are small, some are relatively bigger for private developments mainly. And we look through these case histories, and then we found that most failures, they are induced by sheet power wall, okay? The sheet power wall, those drive into the ground. And then those failures, they are significant. Significant means, I showed you the photos later. What do we mean by significant? Because in your term, the significant may not be significant, okay? Different standards. And they don't actually, okay? Some go beyond 10 meters, but many cases, half of them are within 10 meters. So 10 meters roughly is for 2-level basements, okay? And then in some cases, there's only 1-level basement. And the facilities nearby, okay, usually is low-rise buildings. So that's why you can visualize the consequence, okay? Otherwise, if they are high-rise building, if they are supported by piles, then the kind of like the consequence may be very minor in that case. So this is what I mean by large failure already. In Hong Kong, the definition is almost like if you are affecting public, that they need to close the road, okay? And then they're kind of like chance of a car dropping into the ground because of the incident. It classifies large, okay? It doesn't necessarily mean a death of people or fatal kind of like incident, okay? There's kind of a major disruption to the public actually. This is one of the case, like the hole actually occupy half of the length. And then another case in Central. This one is more tricky because it's located in financial district, okay? So if you have major disruption to the kind of like the traffic, that will cause trouble, okay? So the depth of the collapse is quite deep. We are talking about 4-5 meter deep. So in the conclusion from this kind of like study actually is the workmanship. Workmanship means the site control on site, okay? So either the contractors skip some kind of like length of the pile, so they did not drive the wall deep enough, or the control system has problem, okay, over the entire process. So after that, the government published the supervision code. So the latest revision is 2009 supervision, and this document need to read together with another document, okay? They come together. And in that kind of like document, it defines what kind of a material, the construction works we classify as building works with significant geotechnical content, okay? And that geotechnical content will need to be supervised by the geotechnical stream of people. Other than that, they are supervised by structural stream, okay? So in the excavation works, like the diaphragm wall, sheet pile wall, excavations, grouting, so everything needs to be supervised by 2 streams. One is the structural stream, one is the geotechnical stream of people. So I don't bother go through this, but how we identify how many people we will need for a particular site, that was measured by the value of the work. So 4 million is the basic value. For example, if I have a diaphragm wall, the diaphragm wall is 8 million of kind of like value, okay? Then this basic value is 4 million. That means I need 2, okay? 2 persons to station there to supervise the works, okay? So that's quite a stringent kind of like requirement actually. So even the site is small because, I mean, the price index in Hong Kong is very high, right? So you do need a lot of people to supervise the works. So in the organization, it looks like this. From T1 to T3, we call it. And T3 basically is a graduate with 2 years experience. So junior engineer, you can say. The T3 represent a junior engineer. So these people, they are stationed full-time on site, okay? And the number of people is calculated based on the previous slide. And then the T4, T5, this more representing the professional engineer, like the chartered engineer that may have 1 or 2 years, something like that. So these people, they will visit the site on periodic manner, okay? For example, usually it's weekly kind of manner. So every week, the senior engineer, he needs to visit the site once in order to check whether the design has been implemented on site, okay? And then on top of that is kind of like more senior person, like the registered geotechnical engineer. Currently, I think altogether, there's only around 70 RGE in Hong Kong. Roughly, it's about 300 RSCs in Hong Kong, okay? So the frequency is like that. So the T3 from here, you can see for the highlighted one is 5. 5 means full-time, okay? So that code of practice actually gives you the guideline where you should put people in full-time. And then 4 means weekly inspection. And then 1 means if required, the registered geotechnical engineer will go there to have a look, okay? In some cases, we may go on monthly basis, okay? Every month we visit the site. And this is the checklist, very comprehensive, okay? And I don't bother to show you this, okay? You can have a look on the code if necessary. All right, I just want to highlight few key kind of like observations in Hong Kong compared to other cities maybe. So top down in some kind of like projects, we may prefer to do so, but I mean, in this case, it's very congested kind of like working environment, and in effect, it's not very popular. The most popular one is still the bottom-up construction of the basement. So we excavate all the way to the bottom level, and then construct the base slab, and then all the way up. And one particular reason is because in Hong Kong, the land price is very high. So when the owner or the developer get the land, they want to start the construction already. So they will build the wall, and then as long as they know what's the depth to go for, they can build the wall, go to the depth, and then what is inside, then they can decide later. They can have bigger footprint and smaller footprint, okay? They can adjust. So the bottom-up construction actually gives the developer more flexible to design the final building later on. So that's why this is more popular, far lot more popular in Hong Kong. And for the movement limits, I mean, I think no people in Hong Kong would like to see some cracks in their buildings, or even this very low-rise house, roads, or drying out of their wells, for example. So this is a big news. Even this tiny kind of like crack, it becomes big news in the newspaper, okay? So the government imposed very stringent requirement, okay? We are talking about what does it mean is, for example, like the ground movement. For a deep excavation, the ground movement allowed value basically is 1 inch, okay? 1 inch came from the very old rule of thumb of kind of like when British kind of like was governing Hong Kong. And nowadays we still use 1 inch. But in the old days, the excavation is very shallow, right? For one level basement, 5 meters. Nowadays we are talking about 30-meter excavation, 40-meter excavation, but the rule is still the rule. So it's very changing requirement. So the consequence is we need to pump up the stiffness of the wall or other members. Even in infrastructures, so the green zone is what we are looking for. So the maximum value in some areas perhaps is 50 millimeters, okay? This is already better than the building projects for the infrastructure project, but still low, what can I say is. All right, so this is an example for a new railway station which is under construction now. So only single tunnel comes in, that means double tunnel, okay? So one below, one up. So the station is very narrow because it needs to fit into a narrow street. So it's very deep. We are talking about this depth, 35-meter deep, in order to accommodate 2 platform levels, okay? And the buildings next door is not very good, okay? So we need to provide a lot of cross walls actually, with a diaphragm wall, and then with some cross walls. These are not structures. These are cross walls before you excavate. So very kind of like heavy duty wall, I can say. And after all, still we are talking about maybe 50 millimeter settlement, and in some non-critical area, we may go for like 60 or 70, but it's very kind of like stringent. So that enter into, we need to beef up the wall, okay, very robust wall, and very robust struts. So that's why Yunnan struts in Singapore nowadays are quite popular. In Hong Kong, they provide modular struts, heavy members, okay, they are prefabricated and then joined by bolts on site, okay, they are very heavy duty. You can compare this guy with this strut, okay, very large member. And also the consequence is also we need very heavy pillow, very strong pillow to control the movement, okay? So sometimes the struts may go to 1,200 tons, okay, per strut. This is a very high pillow we are talking about to control the movement. And one critical issue, seepage. I mentioned about the groundwater table is very high. It comes with the sandy material. For example, like this is development near a seafront, okay? This not our project, another project, okay, next door actually. We saw the failure. And they almost ready to cast the binding layer, cast the cap in part of the site. And in 1 weekend, okay, in 1 weekend, the entire site flood. The excavation from this level to that level, that's about 13 meters, 13, okay? And then over 2 days, actually the water depth go up entirely. You can't stop, actually. There's no way to stop the water coming in because it's next to the seafront. So this kind of like failure, if happens, it's quite kind of like a dangerous situation, right? If you have workers working inside, I mean, there are a lot of plants inside actually. They all kind of like submerged into the water. So what happens in this side we suspect is because the actual seawall extent may be wider. So some ship piles actually hit the obstruction and they have some defect. Okay, later on the water just connect from the sea, very permeable rock fill, all the way into the excavation, and there's no way to stop the water from the sea, right? So this kind of like situation occasionally is very kind of like critical for the derailments nearby the seaside. And we also have extensive use of the monitoring instruments as well, because the kind of like the distance between the derailment and the next kind of like existing derailments, they are very close. And for the infrastructures, they affect a lot of the urban area. So whole range of the instrumentation we are using. And then for some important projects, we also use the automatic deformation monitoring system. That's the electronic theodolite that will kind of like survey the targets, okay, in the defined intervals. And also different instrumentation firms, they provide softwares to display the kind of like the results in real-time manner. And then they also send out SMS. So actually I receive many SMS every day. So when they reach the action level or whatever level, okay, in the infrastructure projects, of course. Okay, so I talk about a little bit about the future underground projects. So in Hong Kong, we are lack of flat lands, okay? We are limited by the reclamation. When we try to reclaim, environmental group will come out and protest, okay? We can't make a lot of reclamation. So we have shortage of land. However, I showed you, in Hong Kong, we have hilly terrain. There are lots of like the reserve in this area. This reserve not on the surface, but on underground, okay? So this is the initiative that we try to go underground. So in Hong Kong, in the future, several years or 10 years, very likely we will have more facilities that put underground into the hillside, okay? So we are, Arab is studying the cavern kind of like entire strategy for the Hong Kong actually, so where to put, and then there will be some pilot sites to be selected and then to turn into a real project in the upcoming few years, right? So this is one of the major initiative. Another initiative is railways will never stop their development, okay? They keep adding kind of like lines into the existing ones, okay? So all these lines, mostly they are underground, okay? So in this aspect, we are talking about cavern kind of like formation as well. And in urban area, in some new developments, we need underground space for car park for other usage. And in some areas, like the West Kowloon district, cultural district area, is big site actually. This is the ICC tower. It's a very big site. What is the concept or the scheme is actually we push all the traffic underground and then lift the ground level, okay? There's no car at all. So people can enjoy the kind of like walk around, okay? Can enjoy the area entirely by walking through, okay? If they need traffic, they can go underground. So this kind of like initiative is coming, okay, in Hong Kong. And lastly, I would like to mention about the digital environment. Nowadays, for building projects, M&E projects, they talk about BIM, okay, building information management, okay? And in civil projects, geotechnical projects, we also enter into build environment modeling as well. For example, like this project, if you look at this topography, it looks like a villa development over the terrain, right? So nothing very special. If we do a simulation in what does it means in the temporary situation, actually involve almost like 40-meter cut into the hillside in order to build the kind of like basement structures to allow the ramp to go up. So this kind of like site formation works, we call it site formation works, it's difficult to realize from 2D drawings, okay? If we put it in 3D, it becomes more kind of like easy to understand, okay? So like this one, if we, okay. So if we produce this by GIS, okay, you can turn around, have a look at the different formation level. Okay, you see the shadow, this higher level, slope cut, lower level, and then deeper level. And the elevation of the wall, toe in, etc. So, I mean, this kind of like 3D software, they are not very difficult to use, but they are very powerful, okay, in order to allow the designer as well as the client, the most important, the client to visualize what does it look like, okay? They can't actually visualize from the 2D drawings. So this will become another norm. And in every project, I think in some of your projects also you have kind of like visualization by flying through video. Looks like this, we have boreholes nearby. You can integrate the existing information into this kind of like 3D model, like the existing piles, supporting the piers, etc. The boreholes, the ground conditions, the terrain above ground as well. And so this one is for another kind of major interchange projects, okay? I go all the way to here. So this one is more tricky, okay? In a 2D drawing, for this kind of a network underground, it's not easy to visualize, okay? So if you turn into a kind of like 3D simulation, this will give you a very good idea what does it look like after all, okay? In the kind of like interchange of the two stations. So this kind of like planning tool that help actually for the designer to see what is the critical area need to analyze or to look at, okay? So once you produce with the topography, you will know where actually the design doesn't work. All right, so this is the station I talked about, this major hill cut there. And this time we don't need to have any vertical wall, okay? We try to do an open cut. We are talking about 50-meter deep excavation, okay, in the hillside. And we use kind of like some fiberglass soil nails, some fiberglass. Actually, the fiberglass will allow the pile later on for the property development to penetrate through, okay? So that's one major advantage. And this is the cut when we look down to the south, okay? And look to the north, okay? So this is the building next door. What does it look like? It's quite close to the 3D simulation at the day one, actually. So this is my last slide, actually. So in Hong Kong, I just give you a feel of what are the ELS works look like. So it may be different to a certain extent to your projects in here, but both of us have different challenges, okay? So in Hong Kong, there are lots of challenges, actually, not by the design itself, but design to suit the constraint, to suit the movement limits, etc. That gives you a kind of like headache in order to bring it through. And also we have kind of like more advanced techniques to deal with the complicated kind of like constraints as well, like the 3D analysis, like the simulation, etc. And definitely we need good engineers that can kind of like appreciate the kind of like the constraints and then the appropriate simulation or analysis for the complicated ELS as well to ensure the safety. And finally, it's the quite distinctive kind of like supervision control in Hong Kong that also enhance the safety. In recent kind of like 10 or 20 years, we seldom aware of any failure. Even though the case of flooding, I told you earlier, the wall itself is very stable. Basically, the water coming in, okay, when water coming in, the excavation actually becomes more stable, okay, before you pump the water out. And lastly, yes, one good thing in Hong Kong is all the design codes I have showed you, they are free to download, okay? You can enter into the site if you type buildings department or you type CEDD, okay? You can go to the website and then there are lots of publications. They are all free to download in PDF version, okay? So thank you for your attention.
Thank you very much for your excellent presentation. So why don't we have a few questions from the floor to the speaker? มีคำถามอะไรให้แก่ Keynote Speaker ของเราในวันนี้ไหมครับ ถามได้ทั้งภาษาไทยภาษาอังกฤษนะครับ ถ้าไม่มีก็งั้นก็ขอจบไว้เท่านี้ก่อนนะครับ เดี๋ยวผมขอเรียนเชิญรองศาสตราจารย์ดร.วันชัยเทพรักษ์ขึ้นมอบของที่ระลึกให้แก่ Keynote Speaker ของเราในวันนี้ครับ